Lying silently in the icy darkness of the solar system, where sunlight is no more than a faint whisper, Pluto emerges as a challenging enigma. Discovered in the year 1930, it was once honored as the ninth planet. But in the year 2006, it was downgraded to a dwarf planet in a decision that sparked worldwide controversy. Today, the journey to understand Pluto is not just a scientific pursuit, but also an effort to define its true place in the cosmos. With its strange orbit, icy and surprising surface, and the potential to harbor life, this small celestial body feels both familiar and alien. This story will take us through the history to uncover the unanswered mysteries of Pluto. At the end of the 19th century, scientists Urbain Le Verrier and Percival Lowell noticed small irregularities in Neptune's orbit. This hinted at the presence of an unknown object which Lowell named Planet X. Lowell, founder of the observatory, spent over a decade searching for it, using complex calculations based on Newtonian mechanics to predict the mysterious planet's location. Although he passed away in the year 1916 without achieving his goal, his legacy laid a foundation for future discoveries. The Lowell Observatory carried on the mission. A young man named Clyde Tombaugh, largely self-taught, was assigned to photograph the night sky using a new 13-inch telescope. He used a device called a blink comparator to compare photographic plates taken days apart, searching for movement among the fixed stars. After months of meticulous work, Tombaugh spotted a tiny moving dot among the stars, a clear sign of a new object in the sky. News spread quickly, and on March 13th, 1930, the discovery was officially announced. Humanity had found a new planet, Pluto. The name Pluto was suggested by Venetia Burney, an 11-year-old girl from England. Inspired by the Roman god of the underworld, a fitting name for such a cold and distant world, located an average of 5.9 billion kilometers from the sun. This event was not just a scientific milestone, it ignited global curiosity about the secrets hiding at the edge of the solar system. After exploring the magical history of Pluto's discovery, it is now time to discuss the initial observations and its recognition as the ninth planet. In the 1930s, astronomical technology was still primitive, and Pluto appeared only as a faint dot through the most powerful telescopes of the time. Scientists could not accurately measure its size or mass, leading to incorrect initial estimates. Some believed it was larger than Earth, based on the supposed effects it had on Neptune's orbit. However, observations in the following decade, using improved telescopes and light analysis techniques, gradually revealed that Pluto was much smaller than expected. On March 1st, 1930, it was officially recognized as the ninth planet, expanding the solar system from 8 to 9 members. This event held great historical significance, not only because it extended the known boundaries of the universe, but also because it marked the first time an American astronomer discovered a new planet, a national pride. After advancements in astronomical techniques, it was determined that Pluto has a diameter of approximately 2,377 kilometers, significantly smaller than the Moon and only about 18% the diameter of Earth. This makes it the smallest object ever to be classified as a planet for nearly 8 decades. Its mass is only 0.002 times that of Earth, too small to generate significant internal pressure. Pluto's shape is roughly spherical, but not perfect. Its weak gravity prevents it from reaching true hydrostatic equilibrium, resulting in slight surface distortions. However, these figures may not be entirely accurate, as the reflected light from Pluto is too faint to measure precisely from Earth. It wasn't until the New Horizons spacecraft flew by in 2015 that we obtained reliable data, revealing a striking truth. Pluto is so small that it's hard to believe it was once considered a rival to the major planets. While Pluto's tiny size is a key feature, its icy composition and position on the boundary between planets and smaller bodies in the Kuiper Belt truly illuminate the unique nature of this world. Alongside its remarkably small size, Pluto's surface structure came as a major surprise, deepening the mystery surrounding it. Before the New Horizons mission, scientists imagined Pluto as a monotonous icy sphere, frozen in time due to its vast distance from the Sun. But when the probe sent back the first images on July 14, 2015, a completely different picture emerged. Its surface is a complex mosaic. Towering nitrogen ice mountains up to 3,500 meters high, named Norgay Montes and Hillary Montes, rise from a solid crust. Smooth plains, stretching hundreds of kilometers with nearly no impact craters, and rugged areas filled with ancient craters interwoven with younger terrain. This diversity shows that Pluto is not a static world. It may still be experiencing geological activity, even on a small scale. For example, smooth plains such as Sputnik Planitia are believed to have formed from the slow movement of nitrogen ice, similar to glaciers on Earth, while the ice mountains may result from subsurface pressure pushing the crust upward. The energy source behind this activity remains a mystery, as sunlight and heat are nearly negligible at a distance of 5.9 billion kilometers from the Sun. Scientists speculate that heat released from radioactive decay within Pluto's rocky core could play a key role, though the exact mechanism remains an unsolved puzzle. From its surprising surface, we now move on to explore Pluto's atmosphere, a fragile layer filled with strange phenomena. This atmosphere is composed primarily of nitrogen, making up more than 98%, with smaller amounts of methane and carbon monoxide. At aphelion, when Pluto is about 7.4 billion kilometers from the Sun, surface temperatures drop to around minus 230 degrees Celsius, causing these gases to freeze and settle on the surface like a thin layer of frost. But as Pluto approaches perihelion just 4.4 billion kilometers from the Sun, temperatures rise slightly to around minus 220 degrees Celsius, enough for nitrogen and methane to sublimate and form an atmosphere about 100 kilometers thick. Strangely, this atmosphere is unstable. Pluto's gravity, only 1/15 that of Earth's, is too weak to hold onto gas molecules tightly, allowing them to escape into space at speeds of hundreds of kilometers per hour. Yet, somehow, this atmosphere has persisted for millions of years, possibly thanks to constant replenishment from surface ice or unknown internal processes. Another striking feature is the planet's ethereal haze, a layer of mist formed when methane particles are broken down by ultraviolet rays from the Sun. This haze not only adds to Pluto's air of mystery, but also affects how light reflects off its surface, making it one of the most difficult objects to observe from Earth. Closely connected to the surface and atmosphere, Pluto's most famous terrain feature is the Heart region, Tumbal Regio, also one of the most intriguing aspects of the dwarf planet. This region spans approximately 1,000 kilometers and resembles the shape of a heart, making it the most recognizable landmark from New Horizons images. The western half, known as Sputnik Planitia, is a bright, icy plain composed of frozen nitrogen, methane, and carbon monoxide. Scientists believe Sputnik Planitia was formed by a massive impact in Pluto's distant past, leaving behind a deep crater that was later filled with atmospheric ice deposits. Beneath this icy layer, there may exist a soft, slowly flowing sheet of ice, behaving like a glacier on Earth, which gives the plain its characteristically smooth surface. Another theory suggests the region formed through convection. Warmer ice from below rises, pushing older ice to the sides and creating sharply defined surface boundaries. But what sustains this activity on such a small and distant world as Pluto? The extreme cold and lack of solar energy forced scientists to consider an internal heat source, possibly from the radioactive decay of uranium and thorium within Pluto's rocky core. Still, the scale and mechanisms of these processes remain a mystery, making Tomball ratio a symbol of Pluto's surprising complexity. Leaving behind Pluto's mesmerizing physical features, we now turn to its relationship with other celestial bodies. Unlike traditional planets with nearly circular orbits that lie on the ecliptic plane, Pluto travels along a long elliptical path, tilted 17 degrees relative to that plane. Its distance from the Sun ranges from 4.4 billion kilometers at perihelion to 7.4 billion kilometers at aphelion. And for about 20 years during each 248-year cycle, Pluto actually moves inside Neptune's orbit. The last time this occurred was from 1979 to 1999, when Pluto temporarily became the 8th planet in terms of distance from the Sun. This oddity not only highlights Pluto's unique character, but also raises questions about its origin. Many scientists believe Pluto may be a captured object from the Kuiper Belt, rather than having formed alongside the major planets. Its unusual orbit also affects its atmosphere and surface, as the varying distance from the Sun causes cycles of freezing and sublimation of nitrogen ice. We now explore its relationship with its moons, a small but complex system. The largest moon, Charon, was discovered in 1978 by James Christie. It has a diameter of 1,208 kilometers, nearly half the size of Pluto. This size ratio makes the two bodies a rare binary system. Instead of Charon orbiting Pluto, both revolve around a common center of gravity located between them. In addition to Charon, Pluto has 4 smaller moons, Nix and Hydra, Kerberos, and Styx, discovered in 2005, 2011, and 2012, respectively. All were observed using the Hubble Space Telescope. These moons range in size from 10 to 50 kilometers, and their elliptical and tilted orbits suggest a chaotic past. One hypothesis proposes that Charon formed from a massive collision between Pluto and another Kuiper Belt object billions of years ago, similar to how Earth's moon may have originated. The interactions between Pluto and its moons not only enrich its story, but also offer clues about the origin and evolution of this system at the edge of the solar system. From the relationship with its moons, we move on to explore Pluto's interaction with Neptune, the closest planet in space. Although their orbits intersect, the two celestial bodies never collide, thanks to a 3-to-2 orbital resonance. This means that for every 3 orbits Neptune completes, Pluto completes 2, creating a precise alignment that ensures they always remain at least 17 astronomical units apart, approximately 2.5 billion kilometers. This resonance is not a coincidence, but the result of dynamic stability maintained over billions of years, likely originating in the early days of the solar system, when massive celestial bodies adjusted each other's positions. Initially, scientists believed Pluto was the primary cause of anomalies in Neptune's orbit. However, once Pluto's true size was determined, they realized its gravitational influence was far too small to cause any significant effect. Instead, this interaction highlights Pluto's true nature, not a planet that dominates its orbit, but a modest member of the Kuiper Belt governed by much larger forces. Let us now delve into one of the most controversial events in its history, its demotion to a dwarf planet. On August 24, 2006, at a meeting of the International Astronomical Union, or IAU, in Prague, a new definition of the word planet was adopted based on 3 criteria. First, it must orbit the Sun. Second, it must have sufficient mass to assume a nearly round shape, a state called hydrostatic equilibrium. And third, it must have cleared its orbit of other celestial objects. Pluto met the first 2 criteria but failed the third. It resides in the Kuiper Belt, a region containing thousands of icy bodies such as Eris, Haumea, and Makemake, and it is not massive enough to remove these neighbors from its path. This decision was driven in part by the discovery of Eris in 2005, a celestial object initially thought to be larger than Pluto. This raised a critical question. If Pluto is considered a planet, then shouldn't Eris and many other similar objects be planets too? To avoid diluting the concept of a planet, the IAU created a new category called dwarf planets, placing Pluto alongside Eris, Ceres, Haumea, and Makemake. The decision sparked intense reactions. Many scientists, including Alan Stern, the principal investigator of the New Horizons mission, argued that the clearing the neighborhood criterion was unfair, as even Earth has thousands of asteroids near its orbit that it hasn't cleared. The public also opposed the change, viewing Pluto's demotion as the loss of a cultural icon that had been cherished for generations. Nevertheless, the IAU's definition has remained in place, making Pluto the centerpiece of an ongoing scientific and philosophical debate about how we classify celestial bodies in the universe. Despite its demotion, Pluto has not lost its scientific allure. One of the most astonishing discoveries from the New Horizons mission was the evidence of a hidden ocean beneath its thick, icy crust. Images and data from the year 2015 revealed cracks and bulges on the surface, especially in Sputnik Planitia, which may be signs of pressure from a liquid layer below. Geophysical models suggest that this ocean is composed of liquid water mixed with ammonia or salts, allowing it to remain in a liquid state at temperatures as low as -200 degrees Celsius. The ocean could be between 100 and 150 kilometers deep, beneath an ice shell approximately 200 to 300 kilometers thick. This internal heat is thought to originate from the radioactive decay of elements like uranium, thorium, and potassium within Pluto's rocky core, generating just enough warmth to prevent the water from freezing completely. Some scientists even propose that this ocean might have interacted with the surface in the past, when major impacts fractured the crust, leaving traces like the large fissures seen in eastern Tomball Regio. This discovery transforms Pluto from a lifeless block of ice into a dynamic world, opening new questions about its potential within the solar system. From the hypothesis of a subsurface ocean, we now ask, could Pluto support life? At present, there is no direct evidence of life on or beneath its surface. However, the presence of liquid water, a key ingredient for life as we know it, along with organic compounds such as methane, nitrogen, and carbon monoxide, has led scientists to consider the possibility, if life exists, it might take the form of simple microorganisms, similar to those found near hydrothermal vents at the bottom of Earth's oceans, where sunlight never reaches. The energy needed for such life could come from chemical reactions between water and minerals in Pluto's core, for example, through a process called serpentinization, which produces hydrogen and heat. Some studies even suggest that high pressure within the subsurface ocean could create pockets of methane clathrate, a compound that might play a role in microbial metabolism. Though still a hypothesis, the idea of life on Pluto is no longer far-fetched. It is a possibility worth exploring, one that adds another layer of mystery to this distant world. Looking at current discoveries, we turn our attention to Pluto's breakthrough potential in the future, a truly promising prospect. The New Horizons mission in the year 2015 was only the first step, offering a brief glimpse of the celestial body during a flyby lasting just a few hours. Scientists are now proposing more ambitious missions, such as a lander to touch down on Pluto's surface or a drilling robot capable of piercing the thick ice crust to reach the hidden ocean below. Advanced technologies like enhanced infrared spectrometers, ultra-cold resistant robots, and remote chemical analysis instruments could help detect signs of life or reveal the inner geological processes. Another idea involves sending an orbiter around Pluto, allowing for long-term and detailed observations of its atmosphere, surface, and moons. These missions would not only target Pluto, but could also expand exploration of the Kuiper Belt, providing data on the origins of the solar system and the formation of icy bodies. However, the challenges are significant. The vast distance demands travel times of several decades, high costs, makes it an unmissable target, promising to open new chapters in humanity's quest to explore the universe. Pluto, once honored as the ninth planet and later reclassified as a controversial dwarf planet, stands as a vivid symbol of how humanity's understanding of the universe evolves. Its journey from discovery in the year 1930 to its demotion in the year 2006 is not only a scientific tale, but also a philosophical struggle to define what belongs to the solar system. Though small, Pluto still holds deep mysteries, from its magical frozen heart terrain to a subsurface ocean that might harbor life. In the future, as technology brings us back to this icy frontier, it may reveal answers that far exceed our current imagination. Pluto reminds us that in the vast cosmos, the smallest things can carry the greatest secrets, and its exploration will always be an irresistible call.